Got it.
We've done some really nice experiments with bubbles containing hydrogen gas using our slow motion camera. The experiment was really quite simple. Up here we had a burning spill, just a piece of wood like a large match. And underneath we had a bubble blowing kit, just like this. And we blew hydrogen gas through it because hydrogen gas is lighter than air. The bubbles flew up towards the flame. For me, one of the most surprising things was how hard it is to hit a flame with a hydrogen bubble. Most of our bubbles missed, and they floated up reasonably slowly. And you have to remember that a small bubble has a higher pressure of gas inside it than a big bubble. So if you have a big bubble, the pressure is pretty low, almost the same as atmospheric pressure. But what this means is that if you burst the bubble, the gas isn't under pressure and doesn't expand very rapidly. One of the things that I thought was interesting is that when a bubble catches fire, the burning gas continues to move up, almost the same shape as the bubble. It expands a little bit, but it continues upwards. And the other point that we saw from these bubbles is that even though the soap has disappeared very quickly, the gas still burns with an orangey flame. I think that's interesting because it shows that the gas is still experiencing a buoyant effect and the rising up. And the fact that it suddenly goes to a very high temperature does not really seem to change the rate at which it goes up. Look, this one's quite fun. It's double, just like a hydrogen molecule. I was expecting that this would burst twice as much as a single bubble, but you see, it's more or less the same. So you can't always predict what's going to happen. So it was quite an anticlimax, but it's quite nice to burn a hydrogen molecule containing hydrogen. We've done several videos about burning of hydrogen balloons and whether it's the rubber that causes the colour or it is the gas. So just watch this bubble because it comes up and hits the spill where it's not burning and the bubble bursts. So you have hydrogen gas which is completely free and it goes up into the flame and it burns with the same orange colour. So we have a really nice example which shows that hydrogen gas, when it's not contained anything, will still burn with an orange colour. And almost certainly this is because the hydrogen and the oxygen are not properly mixed. So we were completely wrong that the rubber could possibly have caused the orange colour. And it's always good to be wrong. It shows that you're learning something. I think the really important demonstration from the understanding of gases is how slowly gases spread in air. So even if you have some hydrogen that is not confined by anything, it really takes quite a long time for the hydrogen to spread out. And so this, if you like, challenges our idea that gases and things mix very quickly. Of course, eventually all gases will mix, but on the time scale of the video, everything is pretty slow. And so it is important to learn these lessons and to see how things behave. What we on periodic videos want to do is to try and show you things which make you think and realize the real world is slightly different from what you expect. I've really enjoyed watching this footage, and I'm sure I've missed some quite interesting things. So I'd really like all of you to watch these videos and see if you can notice some extra effects, some other lessons that we can get out of them, and tell us about them in the comments. If it's something interesting, we'll try and make another video.